Hey guys, welcome back to the shop. So we finished up the Extra 260 and I had the maiden flight yesterday, so I thought I would shoot a quick video and just walk you through the setup. Pretty basic, but I'll show you how I do things. So everything's put together. It's the quote patty scheme, but it's not completely scale, so I didn't go all nuts with scale graphics. I just added some of the stickers, put my AMA number on in the same color that the registration number would be, and a few other things. One of the things I like to do, since we're supposed to put our FAA numbers on as well, is I put a little decal behind the pilot with my AMA and FAA number, so we are legal. I'll just pull the canopy and I will show you the setup. So for power, using the standard power system, the AMC 670 motor with the T-motor 18x8 prop. I do like to paint my tips. That's something I highly recommend that folks do for safety, so you can see the prop when it's spinning and stay away from it. It's just a good idea. You don't have to get too worried about upsetting the balance. If you've got a prop balancer, you can paint the tips white, and then I put them on the balancer and use a little quick light spray of clear coat on the lighter blade to get them back into balance. Usually doesn't take very much. Like I said, AM 670 motor. I did make one switch and I put a YGE Safir 125 amp speed control in here because I really like those. I use them on the helicopters. They have really great telemetry integration with the Futaba system that I'm using. So I use their telemetry dongle that then plugs into S-Bus 2 on the Futaba, and that gives me motor RPM, voltage, current, consumed capacity in milliamp hours, also ESC temperature, and the BE side current, voltage, and so forth. There's tons of parameters. One of the things I really like to do in electrics is use that with the capacity telemetry to time my flights. So I happen to be using SMC 4900 HV packs. So I calculate 75-80% of that. I think I set the telemetry to alarm when it uses 3700. So very consistent, and you don't have to worry about setting a timer, and if you're flying harder than usual, you may run down the pack slow. You could also go with voltage telemetry. One thing I realized yesterday over the weekend with flying with the teenagers is that I really should have a voltage telemetry warning as a backup, but that's a story for another day. So anyway, got the SMC 4900 packs. They weigh about what a 4000 standard pack would be. So we did the maiden flight with the battery about here. I actually let Joey do the maiden flight this time. He's never done a maiden on a new build, but he basically flies everything up and including my 70cc gasser, so I trust him. He really liked the feel, very neutral. So I wanted to push the battery up. This is where I liked having the battery, because with the battery back here in this lighter pack, it was so neutral that on the 45 inverted line test, it just kept going straight. It didn't fall at all. So it's a little bit too neutral for me. The rest of the setup is servos. We're using the Theta 989 that EF sells. Really nice, ridiculously powerful. They do have a little bit of play in the gears right out of the box. That's the only thing I've noticed about them that I could say I don't really like. Otherwise, I would have taken anything we could throw at it yesterday. They fit perfectly. The servo cutouts are perfect, even for the motors, which stick out on these. The rest of it's Futaba, running 26SC. I'll actually power that up so you can see. 26SC, what's the nice thing is you get telemetry on the top screen. That's one of the bigger differences from the 18SC that I used to fly, and now I've let Joey fly, which is really nice. So I have it set up so I can see the capacity, voltage, and RPM right there while I'm flying. So if I just want to glance down and look, obviously fastest RX to get the telemetry, and this time I actually threw a gyro on here. I don't use gyros on any of my gas planes, but a couple of electrics, it's nice, mostly for windy days. So when it's calm, this thing flies beautiful. We had a bit of a gusty wind yesterday. You flip the gyro on and you think you're flying a 120cc. That's what I like about gyros on small planes. I wouldn't see a need for them on a big plane. In this case, we're using the Futaba GYA 533. Which integrates really nice. You just have the single S-Bus 2 cable connection from the receiver to the gyro, and everything else plugs into the gyro. Unlike some of the previous Futaba gyros, you can use this on anything, including gas. It does support dual elevators. It supports dual ailerons. You can see I've got aileron 1 and aileron 2. We got just a single elevator, but you can do dual elevators. But anyway, for this, it works great. One of the things about gyros, if you don't use them a lot, or for guys that don't have helicopter experience, gyros are really sensitive to how you mount them, and they usually want a fairly rigid mounting. So you don't want to stick them on a piece of foam with the thought that isolating from vibration is good, because what will happen is it allows it to move, and it interprets any movement of the box as a movement of the plane and will try to correct. So if you have too much vibration isolation, you'll actually get weird oscillations and unwanted movements. So they generally want them pretty rigidly mounted. Most gyros will give you instructions on how to mount them. The very common way is a single layer of 3M gray mounting tape. Lots of heli gyros come with a tape that I think that's what it is. It looks an awful lot like that. And for the mounting tape to work, you need a nice smooth surface for it to stick to. The 3M tape will not really stick to wood or the rough black fiberglass texture. So what I did is a little piece of clear plastic, and I clamped that down with some goop clear silicone adhesive and let that harden, and then I could stick the single layer of 3M tape and my gyros attached to that, right? So it's got just enough isolation from the foam tape and no more. And it sticks on there really good. You don't want to strap it down or anything like that. You don't want the wires going into a gyro really tightly tied down either, because that can transmit weird vibrations. Hold on, we're gonna pause. Okay, we're back again after a little interruption. So now what I've done is plugged everything in and actually connected the transmitter to program mode, so I can show you some of the elements of the setup. I've got a spare battery that I have plugged in for power, so we can power up. One of the nice things about using the YGE ESCs is that, and you can hear everything's just initialized. The YGE ESCs is that they are rated for using with buffer packs hooked up to the BEC power bus. So you can put a small LiPo and set your BEC voltage to something like 7.9 volts. It'll keep the LiPo charged up. And the LiPo is there as a buffer to take any spikes, which honestly, with 20 amp ratings on BECs these days, I don't see why that would be an issue. But it's there, and it's also a backup in case you have a BEC failure, which again, I don't think I've ever had one. But the long and short of that is that since it's rated for that, it's also safe to hook in another battery without disconnecting the ESC. You won't fry anything, unlike some other systems. For instance, I would not try that with a hobby wing. I have seen them fry on the bench if you do that. Okay, so we're all set up. I got everything set up and configured. I have my transmitter hooked up. I like to use on the Futaba flight modes. So I have a landing mode, which is low idle. And this switch here I use for my throttle hold or kill, low idle landing mode and flying mode. I also use that for idle modes on my helicopter, so that's consistent. This switch over here I use for my main flight mode. So I have a normal sequence flying mode, a spin mode, and a 3D mode. I use that in every plane because also on my helicopters, I use that for my idle ups. So I basically think of that as my agility modes on anything. So my sequence mode is typical low rates. So it's got about, I started with 10, 12 degrees in the ailerons. It wasn't enough. It's like I had to bump it up yesterday to 15, maybe even 20, because the low rate roll was too slow for sequence flying. I like about one roll per second, like 360 degrees per second, which is good for sequence. You can have it even slower on your landing mode, but if you're doing like IMAX style sequence, I like about one roll per second. The elevators, I'm usually somewhere, they tell you 8 to 12 degrees. I go more towards 12. For my sequence flying rate, I want the elevator to be just enough so that at high speed, you can pull full back stick and do a tight loop without snapping out, right? So if you're snapping out, you lower the rate until you don't, and that's good. And then a little less than full rudder. Then my spin mode is the same low aileron, but I go to full 3D rudder and elevator for doing flat spins, right? And then 3D mode is high rates and everything. So I've got the rudder just short of touching, the elevator is 50 degrees up and down, the ailerons 38, 40. Because we know from a lot of the pro pilots that any more than that, and they basically just start acting like air brakes and they stall your wings out anyway. Run a lot of expo on the 3D rates, 50 to 60% expo on the 3D rates. 20 to 30% on the low rates. I might actually turn that down a little bit. On my big planes, I need a lot. On these smaller ones, they have a little less energy and momentum. I find that I actually need to turn down the expo on the low rates to get them to feel consistent. One of the interesting things is the gyro. So the gyro can actually be turned off and on in the programming. So Futaba, it's really easy. You go to the gyro menu and you have your gyro 1, 2, and 3, which is your 3 axes, ailerons, elevators, and rudders. And you can have 3 different sets of rates, and you can have them attached to your flight modes or on a switch. In my case, I switch them because I only use it on really windy days. So this is my switch, and I can turn them. I have a no gyro, a medium gyro, and a high gyro. So actually, I'm only using 2 sets of rates. I could have 3 sets of rates. And only rate mode, not heading hold. I know you could use heading hold to have it just hover itself. I've never used heading hold on an airplane. It's more of a helicopter thing. So I can adjust the rates. We were playing around with these yesterday. The gains are pretty low. I have 2 planes that I'm using this gyro, and the other one's the 84-inch Bushmaster. I can run a lot of gain on the Bushmaster because you're flying it pretty slow. And on really gusty days, I've flown that thing in 20-mile-an-hour gusts, and you have the gains can crank up to 70 or 80%, and it holds like it's not even there. The extra, because it flies a lot faster, we found that if we went much over 30 to 40%, we would start to see oscillations. Like it looks like it's fluttering, which is gyro oscillations. And that's how you know you've gone too far with the gain. So you just slowly turn it up and do high-speed passes and watch for oscillations. When you see them, you back off a little bit. So we found right now about 30%. I have to adjust a few things, but that's where we're at. The cool thing that I wanted to show you with the Futaba, and it's an improvement for Futaba. For a lot of other settings are still behind, is we have the integration so I can set things up on the radio. Unfortunately, I have to plug in a wire, and I can go through and adjust my setup. So I go into the menus and go into configuration. You can see the gyro direction, what type of wing, what speed, if you're using digital analog servos, and so forth. You can set up the correction directions. You can adjust neutrals. I didn't need to do that because I did neutral programming of these servos. I got them close with the physical linkages, and then I zeroed them with the data programmer because I like nice 90 degrees. But the thing that's important to know for the Futaba is your servo limits. So airplane gyros are a little less intuitive, I find, to set up than helicopter servos. In helicopter servos, you basically have everything in the radio just default. 100% throws, 0 neutrals, and you set up, and the gyro just interprets the stick motions as a request for movement, and then you set all the physical limits in the gyro itself, right? When you move the stick, you're not actually telling it to move the surface. On a helicopter gyro, moving the stick is saying, I want to roll at X degrees per second, or I want to pitch at X degrees per second. And you set the motion limits in the gyro itself, and then you tune things like rates and agility and the effect of curves and things. It's all in the gyro. Airplane gyro is a little bit different. They tried to keep it simple, but after some trial and error and watching some videos, which I'm not sure I totally agree with some people's interpretations because Futaba's manuals, well, suck. What I did is I first set gyro off, and I use my angle gauges to set my limits. So like for 3D rates, I want 40 degrees of 40 degrees of aileron. I set that up. Then I turn the gyro on, and you go in, and there's actually a servo limit. And you notice when you turn the gyro on the first time that the surfaces will move differently than when the gyro is off. Possibly less, more likely more. So I turned all these numbers down. Then I go in and basically repeat my setup with the angle, with the throw meter angle gauge, as I go to 3D rate full throw gyro on, and I use these adjusters to get to the same ultimate throw. So with the gyro on, there's 40 degrees. With the gyro off, there's 40 degrees on my highest rate. That way I know that it won't overdrive the servo to the point of, overdrive the surface to the point of binding for corrections. It still does some weird things. You'll notice on low rates, you get differences in throw. So here's my low rate aileron, and if I turn the gyro off and on, actually no, I gotta get out of configuration mode. So if I get out of config mode, that's my low rate aileron and if I turn the gyro on, you see there's a little bit more motion. But if I go to 3D mode and I go to full, there's really no difference. So basically what I've done is I've set the limits twice. Once in the radio with the gyro off, and the second time in the gyro setup with it enabled, so that you know you're not going to overdrive anything. You think it's going to create some weirdness, like it'll respond different gyro on and off, but actually in flight it seems fairly similar. It's got something to do with how the gyro programming works. But anyway, through some trial and error, I found that method seems to work. It will seem like the low rate throws are too high on the bench, but in the air it actually feels very normal. So try it out. The nice thing about having it on a switch is if you fly it, always test fly it with the gyro off. If you flip it on and it feels wrong, you just turn it off, land, and make some adjustments, turn some things down. So that's how we set that up. And so far, I really like it. What else to note? I talked about the power system, talked about the electronics, I talked about throws. Oh, antennas. Sorry guys, but I see a lot of people do weird stuff online, especially with Futabas. Your antennas have these, I'll pull this guy out. You have your nice little, you have your antennas, and see, this is a Futaba antenna. This little white wire here at the end, that's the actual active antenna. It's what's called a half-wave monopole. It's about 1 inch long, so 2.4 gigahertz. The whole wavelength is somewhere in the neighborhood of 4 inches long. So this is, sorry, not half-wave, quarter wave. So this little element is called a quarter wave monopole. The rest of the wire is just an extension, and that's so you can get them far enough apart. So you want these, the antennas, these little antennas are fairly directional. They get the strongest reception and signal at right angles to the wire and the least end on. So they give you 2 of them so you can put them at 90 degrees. In theory, no matter where the airplane is oriented relative to your transmitter, at least one of the antennas is going to give you a side view. So don't put them right next to each other. Don't put them like that. Have them at 90 degrees and use these extensions to get them as reasonably far apart from each other as you can. That'll give you good orientation and also the best chance that they won't get blocked by some heavy metal object. So I make little guide tubes, and actually these guide tubes here, if you've never seen these before, these are old push rod, like Nyrod sleeves from back in the days when we built kits and used glow power like 20, 30 years ago. I have so much of this stuff lying around, but any small like plastic tube would work fine. Not carbon fiber. Not carbon fiber, right? Because remember, carbon fiber blocks things. It blocks electrical signals. That's pretty much it. A couple other miscellaneous notes. You may notice that I label my connections. I build a lot, and I have some builds that I put together 10 plus years ago, and I find that I tend to forget how I wired things if I built something years ago and don't come back to it. So I've gotten in this habit of labeling. I just use a Dymo label printer and some clear heat shrink. Put that on. The extensions, I make all my own. I have spools of servo wire and the pins and crimpers. I used Hanson Hobbies for years. These days I actually have a really nice Japanese-made crimper called a Hosen P707, which makes the crimps, they look as good as factory. Hanson is serviceable, and he's a great place to get all the connectors and wires and everything. But the crimpers, the Hosen, it's expensive, but you can get it on Amazon, and it's a 2-step, but the crimps look like they came out of the factory. They're great. So I make all my own leads so I can get them the custom lengths I need and don't have to spend a lot of money buying them. Don't bother too much with sheathing things on an electric because you don't have to worry about too much vibration. But the couple of places where it goes through a former that's got fiberglass, I did put a little heat sink on the wire. You don't have to do the whole wire loom thing on everything. It doesn't really make a difference on electric, and it just adds weight. It's negligible amount of weight, but it is weight. If you like it for bling, that's fine. I don't really care about bling so much as just care about things being neat. What else? I think that's really pretty much it. These things basically go together by themselves. Everything is done for you except making the links and installing the servos and just gluing in the horizontal stab. And even that is so simple now that they notch it out so it's self-aligned, so no more getting out your 40-inch ruler to measure and get everything straight. It's just, you can't really screw it up. So great plane. Ben, Tim, everybody did a fabulous job with this thing. I told Ben that personally because it just flies amazing. It's a great little plane that I can just toss in the back of the car after work. And that's it. Definitely, if you don't have one and you're thinking about a small to mid-size electric, I can't recommend this enough. I'm sure all the 67 series are fabulous. I still have a 60-inch V1 that I've had for like almost 10 years, but this thing, might as well give it that. It's that much better. And honestly, I didn't think that was possible coming from Glow Planes, that the 60-inch V1 was already that much better. So really, great job on this one. I'm really liking it so far. So thanks, guys.